So title is Combination of Resistors. You know, the resistors are the devices, special devices which has resistance. And in the previous lesson I showed you this symbol, these devices are called resistors. So they are special devices. Each of them has some resistance. For example, one of them has 10 ohm resistor, the other one is 20 ohm resistor, 30, 40, 50. So each resistor has a resistance. They are manufactured at some standard numbers. So by combining them in a circuit in series and in parallel, we can make the resistance of a circuit greater or smaller. Now, today's title is about that. So how can we connect them in a circuit? So resistance of a circuit can be increased or decreased. So we can do a change in the resistance of a circuit. We can increase the circuit or we can decrease the resistance of the circuit. And change means this. To do that, we are going to connect more than one resistor in series and in parallel. To increase the resistance of the circuit, we have to connect more than one resistor in series. So series connection increases the resistance of the circuit. To decrease the resistance, we are going to connect more than one resistor in parallel. So now I am going to study them one by one. First, I am going to study this one, how to connect the resistors in series. And after that, I will explain how to connect resistors in parallel. So first title is series connection or combination, series combination or series connection. Series connection means that you are going to connect more than one resistor one after another, so that two resistors must have a single joint. Now in this screen you see that there are three resistors. R1 is the resistance of the first one. R2 is the resistance of the second one. R3 is the resistance of the third one. So I'm going to connect these resistors in series. So each resistor will have, two resistors will have a single joint. For example, R1 and R2. I will connect them. So R1 and R2 has just single joint. This one is a joint for R1 and R2. R2 and R3, I will connect them. They will have a single joint. Yani, this is series connection. You will connect the resistors one after another, just like when sometimes students are playing game, they're holding hand to hand. Just like hand to hand they are holding. This is the end-to-end connection from one end to the next end. So they are touching each other just like this. They have joints. But there are two additional joint in here and in here. One of them is on the right end, the other was on the left end. This joint must be attached to the battery. So this is a symbol of the battery in electric circuit. So we are going to connect other two ends, one of them is on the right, two on the left, to the battery. So this combination, this connection in physics known as series connection. Now R1, R2 and R3 are connected in series. Series connection has some characteristics. I'm going to now explain them one by one. First one, for resistors connected in series, the same electric current passes through each resistor. What does it mean? How much electric current leaves the battery, say that I, the same current continues through the wire, passes through the first resistor, then passes through the second resistor, then passes through the third resistor, and finally comes to negative again. Yani, resistor 1 has the electric current I1, say that. Resistor 2 has an electric current I2. Resistor 3 has an electric current I3. These electric currents are equal. In I1, I2, I3, which are the electric currents through each resistor, is equal to I. What is I? Electric current provided by the battery. The first most important characteristic of series circuit is this. Electric currents are equal. Second characteristic, Potential differences across the resistors are directly proportional to resistors. What does it mean? So, previous title, the last title we studied in the holiday, was this, Ohm's law. Ohm's law is I is equal to V divided by R. So if we divide potential difference on a resistor to the resistance of the resistor, I will get electric current of that point or that resistor. So now I am going to divide V1 by R1 to get I1. I will divide V2 by R2 to get I2. I will divide V3 by R3 to get I3. These are equal because electric currents are equal. These are equal. V1 over R1 is equal to V2 over I2 is equal to V3 over I3. Yani, what does it mean? So this is constant, result is constant. What does it mean? If resistance is greater, potential difference must be greater. If resistance is smaller, potential difference must be smaller. Yani potential difference across the resistor. Say that potential difference across the third resistor is V3. Say that potential difference across the second resistor is V2. Say that potential difference across the first resistor is V1. These potential differences and resistance are direct proportional. Yani greater resistance will have a greater potential difference. Smaller resistance will have a smaller potential difference. So these two are two important characteristics of series connected circuits. Now I am going to solve a problem about these two characteristics. After that I will continue the next two characteristics. For example, look at this example. Two resistors are connected in series. How can I understand that? Because each resistor has just one single joint. And other two ends, K and L, attached to the battery, as you see. These two resistors are connected in series. Question is asking you, the potential difference across resistor 2 is 20. Resistor 2 is this one. Yani V2 is 20 volt across the resistor 2. What is potential difference across resistor 1? So find V1. This is question. So we know that both resistors have the same electric current because in series combination, electric currents are equal. And I1 and I2 are equal. If electric currents are equal, I can write that I1 is equal to, according to Ohm's law, V1 over R1. I2 is equal to V2 over R2. So then I can insert V1, R1, V2, R2. V1 is unknown. I will calculate V1, but R1 is known. How much is R1? 5 ohm. Write 5 equals V2 is how much? It's given in the question as 20. How much is R2? 10. So by the help of this equation, I can calculate what is potential difference across the first resistor. So continue. V1 divided by 5 is equal to 20 over 10 is 2 cross product. V1 is equal to 2 times 5, which is equal to 10 volt. Yani potential difference across 5 ohm is 10 volt, while potential difference across 10 ohm is 20 volt. Is it logical? Yes, because resistance from 5 to 10 doubles. So potential difference from 10 to 20 also doubles. This tells you that potential difference is directly proportional to the resistance of the resistor. Third characteristic is this. Sum of the potential differences across each resistor or resistors is equal to potential difference across the terminals of the battery. Yani potential difference of the battery is sum of the potential difference across each resistor. I am going to add them. Potential difference across the resistor 1 plus potential difference across resistor 2 plus potential difference across resistor 3. Yani V1 plus V2 plus V3 will be equal to potential difference across the battery, V. So this is the third characteristic. Now I am going to apply this third characteristic to the question we solved just before. In this question, remember, potential difference across the resistor 2 was given as 20 volt. 10 volt, sorry. If this is 10 volt, a potential difference across resistor 2 is 10 volt. So then you tell me, what is potential difference across 5 ohm? What do you think? V1 divided by R1 is equal to V2 divided by R2, sorry. V1 is unknown, R1 is 5, V2 is 10, R2 is 10. As 10 over 10 is 1. Cross product, 5 times 1, it becomes 5. Yani V1 is 5 volt. Half of V2. Okay, now let's apply this rule. What is the potential difference of the battery? We know that potential difference of the battery is the sum of the potential difference of every resistor, all resistor. There are 2 resistors, so I'm going to add potential difference of each resistor. So V is equal to V1, I just calculated as 5 volt. V2 is given in the question as 10 volt. So add them, 5 plus 10, potential difference of the battery is going to be 15 volt. Now, fourth and last characteristic. Fourth characteristic is this. It's about equivalent resistance. Equivalent resistance are equivalent of the circuit. What does equivalent resistance, what does it mean? Now, first, let me explain that. As you see in this circuit, there are 1, 2, 3 resistors. So, I can represent this circuit only by 1 resistor instead of this 3. I will draw just a single resistor instead of this 3 resistor. That single resistor is called equivalent resistance. Yeah, instead of 3, I am going to use a single resistor. That resistor is called equivalent resistor or equivalent resistance. In series combination, we are going to add resistor 1 by resistor 2 and resistor 3. We will add them all. When we add them all, we will calculate equivalent resistance of the circuit. Say that R1 is 2 ohm, R2 is 5 ohm, R3 is 7 ohm. So what is equivalent resistance of the circuit? So just write them. R1 is 2 plus R2 is 5 plus R3 is 7. Add them all. 2 plus 5 is 7. 7 plus 7, 14 ohm. Yani equivalent resistance of this circuit is R equivalent 14 ohm. What does it mean? Instead of connecting these 3 resistors in series one after another, find a 14 ohm resistor, put it into the circuit. Why are you using 3 resistors? Use just single resistor. Equivalent resistance means that. Now let's do one more exercise, and after that I will continue the next combination, which is parallel. In this circuit, calculate equivalent resistance. How many resistances are there? 3. R1, R2, R3. Add them all. So equivalent resistance is going to be 2 plus 3 plus 4. It's going to be 2 plus 3, 5. 5 plus 4, 9. So equivalent resistance of this circuit is 9 ohm. What does it mean? Instead of this 3 resistor, just single resistor, which is equal to 9 ohm, can be used. Equivalent resistance means this.